Please get out your pencils, your pen, and your paper to start writing. Any math video that you are looking at and listening to, you must be putting pen or pencil to paper to be practicing routinely. Okay, please make that a routine, common practice when you are looking at math videos. So we are going to be translating words to symbols with exponents and powers, because mathematics is basically a quantitative language. And what it does, it translates words using symbols, because remember, we think using words. Okay, when we think, we are thinking words, and then this has to be written. Okay, so to facilitate the efficiency of writing maths, symbols are created to translate those words. Okay, here we are going to continue giving examples with exponents. Example 6 and 7. So I'm going to read this little paragraph here. Now, ax all raised to the exponent or power of n, all raised to the exponent or power of m, is ax all raised to the exponent or power of n times m. So there are some keywords here that we can use to facilitate the translation. All right, ax is almost looking like a symbol already, so it doesn't really have to require translation. Raised to the exponent of power, this has a symbolic translation. Okay, and times, the symbolic translation of times is multiply. Okay, so let's do that here. Ax normally, when we are writing in mathematics, it's normally written in italics. So ax, see the difference in italics. Ax all raised, so all raised, now we will need brackets. All raised, because both the a and the x have to be raised. When they say all raised, both the a and the x have to be raised. Okay, so we can even highlight the word all as an important word in mathematics. All, we enclose in a bracket, normally call the bracket the mathematical basket. You put all of them in the basket. All has to go in the bracket. So you see the similarities with the English language. All raised to the power of n. So both the a and the x are being raised to the power of n. Okay, then it goes on to say all of that. So let's put all of that in brackets. Let's look for brackets. Let's use a different bracket, because to differentiate between brackets. Okay, so all of that being raised again to the power of m. Okay, so a situation like that is equal to the ax all raised to the power of n times m. N times m. All right, nm is the same as n times m. So you call that the powers raised rule. Okay, so for example, we can use x as our base. Let's say you have 5x all raised to the power of 2. Five x all raised to the power of 2. And then this in turn now the 5x to the power of 2, or the exponent of 2, is raised again to the power of 3, for example. Okay, is equal to the 5x all raised to the power of times 3. Okay, and 2 3s are 6. So that will be equal to 5x raised to the power of 6. Okay, they call that the powers raised rule. Now you have another rule. It says any quantity divided by itself is 1. And it is the same as any quantity raised to the exponent of or power of 0, which is equal to 1. All right. Any quantity, we can use x. All right. Any quantity divided by itself, that's x over x, is equal to 1. Okay. 5 divided by 5 is 1. 10 divided by 10 is 1. So x divided by x is 1. X can only go into itself once. However, we can recall from the division rule that when the base are the same and we are dividing, we can subtract the powers. The power or the exponent here is 1. So x divided by x is also equal to, so that's why we continue the equal sign, x raised to the power of 1 minus 1. And 1 minus 1 is 0. So this is x raised to the power of 0. So in turn, if we have to go back to the left, because in mathematics, you can read from left to right or right to left, x to equal to x to the power of 0 is equal to 1. As you can see, the equal sign is continuing. X to the x divided by x is 1, which is equal to x to the 1 minus 1, which is equal to x to the 0. So 1 is equal to x to the 0. X to the 0 is equal to 1. Equal to 1. So for example, if you have a situation of, let's say, y raised to the power of 0, you can easily equal 1. Okay. If you have a situation of 58h, let's say h, decide to use h, raised to the power of 0. And as you can see, it's only h alone that's been raised to the power of 0. This is equal to 58 times 1, just to show you that h to the 0 is 1. This is 58 times h to the 0. 58 times 1, because h to the 0 is 1, which is the same as 58. Okay, so just remember, any quantity raised to the power of 0 is equal to 1. Any quantity. If you have a quantity and it is raised to the 0, anything we put inside there, we could put any quantity there. We could put x, v, b, x, y, whatever you put inside there, raised to the power of, let's say, 7, whatever you put inside there. Once all of it is raised to the power of 0, anything raised to the power of 0 is equal to 1, because anything raised to the power of 0 is that same thing divided by itself, which is 1. And powers raised, you multiply the powers for powers raised. So please be practicing this routinely. Have your pencil, your pen and your paper writing. Okay, that's how you assimilate the knowledge, the mathematical knowledge, by actually practicing routinely by writing. So please be doing that now.